topic, that is unit 13, symmetry. Yes, friends. So today our topic is symmetry. First of all, students, what is the symmetry? The figures and objects which are made symmetrical. Symmetry means all parts and all size, the length, width, and all parts are equal. The figures and objects which are made symmetrically are known as symmetrical objects. In other words, you can say figures, objects, or structure which having even a balanced portion are known as symmetrical objects. In another way, in very simple way, you can say a figure or a structure which we can divide two or more than two equal parts. Then these figures and the objects are known as symmetrical objects. The figure or an object which is divided equally in two or more than two parts are known as symmetrical figures or symmetrical objects. For example, here now we have few figures of symmetrical objects. For this, friends, now open your books, page number 263. Now, here we have example of a few symmetrical objects. You can see first figure. This figure, first figure is this. This figure is divided into two equal parts. The dotted line shows two equal parts. So this is a symmetrical figure. Next is kite. Also, the dotted line divide into two equal parts. So this is a symmetrical structure. So there are few examples of symmetrical objects. All figures are divided into two equal parts. So these all 6 figures are symmetrical figures. So the figure or an object which we can divide equally two or more than two parts are known as symmetrical figures or symmetrical objects. Clear, friends? Our next part is how we can find the line of symmetry. To find the line of symmetry for the figure, for this, for example, now here we have I have a rectangular shape of paper. Now we find the line of symmetry of a rectangle. Now this space is in rectangular shape. To find the line of symmetry, you just fold this paper and join all parts like this. Now you can see corners are matched. Now open it. Now you can see your sheet is equally divided into two equal parts. So the line which divides the figure or an object into two equal parts is known as the line of symmetry. Here our line of symmetry is this folded paper, folded line. The folded line shows the line of symmetry. Now, how many line of symmetry rectangle have? First, we fold this paper as this. So first line of symmetry is this one. First, now fold it vertically. Now fold this paper as. Again, this paper is divided into two equal parts. So second line of symmetry is this fold. So it means a rectangular have two line of symmetry. First line of symmetry is this, and second line of symmetry is this. So a rectangle having two line of symmetry. The folded line, basically fold the paper or a figure where we fold. This line is known as the line of symmetry. So in a rectangle have two line of symmetry. Now students, now join the corners of this sheet. Yes, students. When you fold diagonally, now you can see it's not divided into two equal parts. So it means this fold is not a line of symmetry of this rectangle. Clear? So basically, in a rectangle having only two line of symmetry, first line is this, and second is this. First line of symmetry of rectangle is this, and second is this. Now, next example is a square. Now find the line of symmetry of a square. Again, hold your paper as. So first line of symmetry of a square, this. Now second is yes, friends. Now see, first line of symmetry is this one, second is this one. Now friends, join the corners. Join the corners of the square. Yes, friends, in a square, when we join the corners, you can see this paper is also divided into two equal parts. So third line of symmetry is sliding line. Now fourth line of symmetry is so it means, friends, a square has four lines of symmetry. First is this one, first line, then second is this second, then third diagonally, and fourth. So you can see two examples, rectangle and square. This is a rectangle. A rectangle has only two lines of symmetry, but a square has four lines of symmetry. For this, students, from this way, we can find the line of symmetry of any object. Yes, friends. Now it's just a few figures having the line of symmetry. Line of symmetry of figures. Yes, friends. Now open your books, page number 264. Open your books, page number 264. Now, students. Now this is the line of symmetry of few figures. In each case, the dotted line or lines of the axis of symmetry. First is a line segment. Now here we have a line segment. The dotted line shows the line of symmetry of this line segment. So students, line segment, a line segment has only one line of symmetry, the perpendicular bisector of the segment. This is a line segment. This is a point A and B. And dotted line shows the line of symmetry. So we can say a line segment have one line of symmetry. A line segment has only one line of symmetry, the perpendicular bisector of the segment. Clear, students? Next is an angle. Next is an angle. An angle has one line of symmetry. For this student, this is an angle. Suppose this point is AOB. This is an angle AOB, and this dotted line divides this angle into two equal parts. So we can say an angle have one line of symmetry. This dotted line shows the line of symmetry of an angle. Yes, friends, an angle has only one line of symmetry, the bisector of the angle. Bisector means when we divide any angle into two equal parts. The line which divides an angle into two equal parts is known as the bisector of angle. Clear, students? Next is a scalene triangle. Yes, students, the type of triangles in scalene triangle, as you know, in a scalene triangle, all three sides are different in length. Line of symmetry of a scalene triangle. In scalene triangle, students, all three sides are different in length. This is a figure of an scalene triangle. Yes, friends, a scalene triangle have no line of symmetry. So, in other words, you can say scalene triangle is not a symmetrical figure. In scalene triangle has no line of symmetry. Now try to find the line of symmetry. First we fold this triangle imaginary, fold this triangle on vertically, then fold horizontally. You can see this triangle have no line of symmetry. We can't divide this triangle into two or more than two equal parts. So students, in a scalene triangle has no line of symmetry. A line segment has one line of symmetry, an angle also have a one line of symmetry, and a scalene has zero line of symmetry. No line of symmetry means zero line of symmetry. Next is isosceles triangle. An isosceles triangle has one line of symmetry. Yes, students, as you know, in isosceles triangle, we have two sides are equal in length. In isosceles triangle, two sides are equal. So in an isosceles triangle has only one line of symmetry. Yes, students, this is an isosceles triangle, and dotted line shows the line of symmetry of an isosceles triangle. So students, an isosceles triangle has only one line of symmetry, the bisector of angle including between two equal sides. Means divide this triangle into two equal parts, then you can find the line of symmetry. Next is an equilateral triangle. Yes, friends, an equilateral triangle, as you know, in an equilateral triangle, all three sides are equal in length. So an equilateral triangle has three lines of symmetry. This is an example of equilateral triangle. Three sides. First line of symmetry is this one. Second is this, and third. An equilateral triangle having three lines of symmetry. First line of symmetry, this one. Second, then third. So students, in an equilateral triangle, we have three lines of symmetry. So see once again, students, If we see the line of symmetry of a triangle, a scalar triangle have no line of symmetry. In scalar triangle, all three sides are different in length. In scalar triangle, we have no line of symmetry, and in an isosceles triangle, we have one line of symmetry. An isosceles triangle, we have one line of symmetry, and in an equilateral triangle, we have three line of symmetry. Scalar 0, isosceles one line of symmetry, and equilateral triangle three lines of symmetry. Clear, students? Next is a parallelogram. A parallelogram has no line of symmetry. You can see this is a parallelogram. Now fold this figure. We can't, by folding, we can't find the line of symmetry. So it means a parallelogram has no line of symmetry. Next is isosceles trapezium. Yes, beta, this is a figure of a trapezium. Isosceles trapezium has one line of symmetry. And isosceles trapezium has one line of symmetry. Next is, next figure, a rectangle. To find the line of symmetry of a rectangle, first fold this rectangle horizontally, then vertically. Fold this figure horizontally, then vertically. You can find the line of symmetry. So in a rectangle, we have two lines of symmetry. First is first line of symmetry, then second. A rectangle has two lines of symmetry. Clear, students? Next is a rhombus. A rhombus has two lines of symmetry. You can see the line of symmetry of a rhombus. A rhombus has two lines of symmetry. These dotted lines shows the line of symmetry of a rhombus. After folding this figure, you can find this line of symmetry. Next is a square. Yes, a square. A square has four lines of symmetry. First, second, now fold the square diagonally. Third and fourth. A square has four lines of symmetry. First and second are horizontally and vertically. Horizontally and vertically. First, second, now third line of symmetry. Third, then fourth. So it means a square has four lines of symmetry. A rectangle has two lines of symmetry. A rhombus has two lines of symmetry. But in a square, we have four lines of symmetry. Horizontally, vertically, then two diagonals. A square has four lines of symmetry. The line joining midpoints of opposite sides, then diagonals. These are midpoints and these are two diagonals. Clear, students? Next is a pentagon, a regular pentagon. As you know, students, in pentagon we have 5 sides. A pentagon having 5 sides. Regular pentagons means all 5 sides are equal in length. A regular pentagon means all 5 sides are equal in length. Yes, friends, a regular pentagon having 5 lines of symmetry. Regular pentagon having 5 lines of symmetry. Now count. First is first, then second, third, fourth, and fifth. To find the line of symmetry of a pentagon, you just point the vertices with the midpoint of side. To find the line of symmetry of a regular pentagon, you just join the vertex with midpoint of side. For example, first line of symmetry, first, second, third, fourth, and fifth. So a regular pentagon has 5 lines of symmetry. Next is a regular hexagon. Yes, students, in hexagon we have 6 sides. A regular hexagon having 6 lines of symmetry. Again, students, to find the line of symmetry of a regular hexagon, you just join the vertex. This is vertex with midpoint of line segment. This one. 2. Now count the line of symmetry. First, second, third, fourth, fifth, then sixth. So a regular hexagon has 6 lines of symmetry. The lines joining the midpoints of opposite side. How we can find the line of symmetry of a pentagon and a hexagon? For this, students, the perpendicular drawn from vertex to opposite side to find the line of symmetry of a pentagon. The perpendicular drawn from vertices to opposite side. And to find the line of symmetry of regular hexagon, the lines joining the midpoints of opposite side and the diagonals through the center. From this way, students, we can find the line of symmetry of a regular pentagon and hexagon. Next is kite. A kite has only 1 line of symmetry. The diagonal shown dotted in the adjoining figure. This is a kite, and a kite has only 1 line of symmetry. Arrowhead, this figure is also having a 1 line of symmetry. Next 2 figures are semicircle and a circle. This figure is semicircle. Yes, students, a semicircle having only 1 line of symmetry. A semicircle having 1 line of symmetry, and this is a circle. Yes, beta. A circle having unlimited number of lines of symmetry. You can draw unlimited lines for symmetry. So students, a semicircle having only 1 line of symmetry, but a circle have unlimited line of symmetry. You can draw the line of symmetry of a circle through center and touch the boundary line. In other words, you can say each diameter is a line of symmetry of a circle. So a semicircle having only 1 line of symmetry and a circle having unlimited line of symmetry. Next is line of symmetry of a figure of letters. Next is line of symmetry of letters. Letter A having only 1 line of symmetry. B again, one line of symmetry. C, one line of symmetry. D, one line of symmetry. And H, two line of symmetry. Letter H having two line of symmetry. Same I, two line of symmetry, first and second. Letter M, only one line of symmetry. Letter O, having two line of symmetry. Clear, students? Now, few examples. Now, in you can see second example. In second example, we have 8 figures. Now, find the line of symmetry of these objects. First is log, then bucket. Now, students, find the line of symmetry of these objects. First is a log. First figure, we have one line of symmetry. Second, again, one line of symmetry. Third, we have 4 line of symmetry. 1, 2, 3, and 4. Third figure having 4 line of symmetry. Next is, again, next fourth figure. Fourth figure, again, we have 4 line of symmetry. 1, 2, 3, and 4. Figure 4 having 4 line of symmetry. Next, fifth figure, we have 2 line of symmetry. Next is sixth figure. In this figure, we have 6 line of symmetry. Now count. First, divide this figure into 2 equal parts. 1, 2, 3, 4, 5, 6. So this figure having 6 line of symmetry. Next is yes, students.
Excuse me, Ria ma'am. Last 5 minutes are left only.
Okay. Now, students, in first figure, we have 1 line of symmetry. Again, 1 line of symmetry. This figure, 0 line of symmetry. This figure having 4 line of symmetry. Again, 4 line of symmetry. Sixth figure, we have 2 line of symmetry. And in seventh figure, we have 6 line of symmetry. In eighth figure, no line, 0 line of symmetry. And last, we have only 2 line of symmetry. So students, today your homework is try to solve question first and second of exercise 13.1. Yes, students, your homework is solve question first and second of exercise 13.1. Thank you. Have a nice day.